Hello student, welcome to the fourth modules of the course Analog and Digital Electronics of the first unit Design of Combinational Circuits. And in these four modules we are going to be studied the very important topics, the Karnaugh map. Abbreviated we call it as a K map. But what is the K map? Firstly we have to start it with the help of these formal definitions. The K map is nothing but the array of cells which is including the columns and the rows. We have to see there are the depends on the input variables how the array of cells are contained. The cells are arranged in such a way that the simplifications of given expressions is simply a matter of properly groupings of cell. In case of K-map, the grouping of cell is important, and how we can make the group of cell, what is the priority of grouping of cells, we have to see in details in the preceding slides. The K-map can be used for the expressions with the 2, 3, 4 and 5 variables. Means it's clearly stated that this K-map is capable to simplify a maximum 5 variables and minimum 2 variables also. Okay, so this K-map is simplification techniques. In previous modules we have to study one of the simplification techniques, namely as a Boolean algebra techniques, but it requires to be a knowledge of rules and the laws of the Boolean algebra in order to simplify, and whatever the final answer we are getting, that is the exactly simplest form or not, we are not confirming. So that's why we are moved to the K-map. For 2 variables input, the K-map in case of SOP, and student please keep in mind the SOP is nothing but the sum of product, and in case of SOP is there, the zero meaning is nothing but the variable complements, or complement of variable is nothing but the zero digital digits. Okay, so whenever during this course of digital electronics the SOP is there, so keep in mind we must have a complement of variable. Okay, so in case of 2 variable K-map for the SOP, so the zero meaning is nothing but a complement of a variable, because this zero value is assigned to a value. Similarly for the B value is 0, means it's a B complements. Similarly for B is equals to 1 is nothing but it's a not or uncomplemented variables. Okay, so that is the important things for the SOP. Now 2 variable K-maps, it's shown here, it's a 4 cell K-maps where the 2 input variable, namely as the A and B, we have to return MSB to LSB like that, MSB from bottom side and LSB from upper side. The value of A is either 0 or 1, the value of B is either 0 or 1, so both values can be. So what is the value of this first cell? It's a into B, so row into column if we multiply it, so the value of this first column is a 0 0, that is nothing but A value is the 0, B value is the 0, but whenever in case of SOP the value is 0 is nothing but complement, so we are showing here the A complements and B complements. Similarly for this second cell, you have seen here the value of the second cell is A value is the 0 and the B value is the 1, while in case of 0 value we are giving a complement to that variables. Okay, so that's why A complement B, A bar B we have to show in this second cell. Similarly for third cells, we are identify the row into column. So row, if we multiply this row into column, so we are getting 1 into 0. 1 into 0 is nothing but the value of A is the 1 and value of B is the 0. Here in this case the value of B is 0, hence it's a B bar. So A, B bar, the location of this cell. Now for the fourth cell, row into column if you multiply it. So from the row sides the value of A is 1 and from column sides the value of B is the 1. So that's why it's a 1 1. So without complements A and B we have to show here. So this is the two variable K-map for SOP. Similarly for three variables we have to make a 8 cell K-map 2 to the power 3, that is the 8 cell, because three variables we are going to be used 2 to the power n. We are going to be utilize this formula for determinations for the cell in the K-map, and the n is nothing but input variables, where the input variables is, so 2 to the power n is nothing but 2 to the power 3, so there is a 8 cells in the three variable K-map. AB is the first two variables and C is the third input variables of this three variable K-map. So for the two input variables, the four possibility is shown here. Either the both input is 0, either the both input is 1 1, either the first is 0, second is 1, or vice versa. Similarly for the single input is either it's a 0 or either it's a 1. Okay, so student, find out this the first cell value from the row into column. From the row side the A and B value both are 0, and from column side the C value is again 0. So that's why it's giving A bar, B bar, C. Why? Because when the value of variable is 0 in case of SOP, it's a complement of variables. Similarly for this second cells, the value of A is 0 and B is 1. So that's why A bar B, which is product terms to the C, the value of C is from column side, it's a C 0. So that's why complement of C we have to show here. And similarly we are proceeding for the all the 8 cells in the three variable K-map. All these terms we call it as the product terms, and in case of SOP we are summing that product terms, so that's why we call it as a SOP. It's a sum of product. In case of 4 variable K-map, 2 to the power 4 is nothing but 16 cell is available, and from the first cell the location is AB 00, from CD column side 00 value is there, and in case of 00 it's a complement of variable. Okay, so that's why A bar, B bar, C bar and D bar is there. Okay, similarly you have to find out the location for this cell. So here is a, from the row side it's a value of A and B is the 1 1, and from column side the value of C and D is the 1 1. So that's why it's a A, B, C, D like that without complements, because its value is 1. And similarly for all the locations we have to indicating in this way. Each cell contain a single product terms, and these are the 16 product terms we have to shown here. Now this is the two variable K-map, but for the product of sum, POS. So product of sum, so keep in mind 0 is nothing but non-complemented variable, but the 1 is nothing but complementation of that variable. We are giving a bar whenever the value of the variable is 1. For the 4 cells, the another one changes is nothing but we are ORing these two, because this is the sum terms. We are making the product of sum terms. So that's why each and every locations we are indicating by the sum terms. Okay, so the value of this cell is nothing but from the A side it's a 1, from the B side it's a 1, and in case of 1, in case of POS the 1 is nothing but the complement of that particular variables. So that's why A bar is ORing with B bar, means these are the sum terms. Similarly for this location we have to calling it A value is 1, B value is 0, so A complement and ORing with B. In case of these locations, A value is 0 from the row side and B value is 1 from the column side, and that's why this product terms is indicating A ORing with B complements. And for the last one is nothing but A value is 0 from row side, B value is 0 from the column side, so that's why it's A ORing with B, and this is the two variable K-map for the product of sum. Similarly for the three variable K-maps, we have to find out from the row into columns, we have to find out the variable values, and accordingly we have to giving the complement to that variables or uncomplement of that variables. So for this particular locations, the AB value is 1 1, from row side AB value is 1 1, and from column side C value is again 1. So that's why A bar is ORing with B bar is ORing with C bar. So this is the location for these particular variables in a 3 variable K map. So similarly we have to show all the value, and student, you have to keep practicing that how we are locating each and every variables or each and every location's value we have to find out. Similarly for the 4 variables, 16 cell is there, as we have already seen in the SOP. So row into columns you have to summing. So from this row side and the column sides you are giving. The one of the question is arises that the value of this from AB is 0 0, then it can be becomes to a 0 1, and for third terms it becomes to be directly 1 1, and then it's going to be a 1 0. But what does it means? This is the gray coding, and we have to already studied in the first modules what is the gray code. So gray code is only differ by a single bit during a sequential or successively value. Okay, if we are switching from this first value to second value, these are the successively following values. So there is only one bit is going to be changed in case of gray code. So this AB value is the 0 0. So the A value is not going to be changed, but the B value is changing from 0 to 1. The only one bit is changes allowed in case of gray code. Similarly for this second value to third value, if we are switching, so you have to see that the B value is 1 in case of previous case, but the B value is same switching to the next case where the A value is going to be changing. Bit of this A value is changing. And similarly for third to fourth, if we are switching, so A value is same, but the B value is going to be changed. So you have to keep in mind, it's a gray coding, it's a 0 0 0 1 1 1 and then 1 0. Okay. Cell adjacency, adjacent cell we have to identify while we are going to be making groups of ones, groups of zeros in case of POS. Okay, in case of SOP. So we have to see in detail the grouping, but before we are grouping which cells is adjacent to each other, we have to see in here. So only the verticals or horizontal cells are adjacent to each other, and one of the very important cell adjacency is nothing but corner to corner, because this cell is adjacent to this bottom side cell, because these are the infinite seed of this K map and it's continuously is going to be carried out. So this is nothing but corner to corner adjacent to each other, from upper cell to bottom cell, lower cell. Similarly for right cell, extremely right cell is adjacent to the extremely left cell. These are the left to right adjacency or top to bottom adjacency for K-map. So K-map SOP minimizations we are going to be utilized here for simplification of Boolean expressions to their minimum form. And the minimized SOP expressions contains fewest possible terms with the fewest possible variable per terms. So that is the aim of the K-map, to minimize the expressions to fewest possible terms which having a very few variables, and it's nothing but the very low numbers or very reductions of the logic gates. That is the only the aim behind that minimizations, because if the logic get reduced, then obviously the cost of that digital circuit is going to be reduced. Okay, so generally a minimum SOP expressions can be implemented with a fewer logic gates than a standard expression. Means whatever the expression is there, using K-map we have to simplify it, and after simplifications we are getting a few variable per terms. Nothing but we required a very less number of logic gates as compared to the given standard expression. Mapping of standard SOP expressions. Okay, we have to see in this 3 variable K-map for SOP. Okay, earlier slide. Now how we can mapping standard SOP expressions. These are the standard SOP expressions, and we are mapping. We are taking the one examples here, A, B bar, C, and we are indicating this A, B bar, C locations as a 1. So where is the A, B bar, C? So this is the A, B bar, C is shown here. Okay. So for that particular locations, we are mapping 1 values for SOP expressions. In case of POS, we are indicating a zeros values. Okay. So in case of SOP, whatever the variables or expressions or the product terms, if you want to represent in the K map, is indicated by a value or digit of 1. The mapping of standard SOP expressions, we are taking the full examples. These are the standard SOP expressions because these are the product terms, and we are sum of these 4 product terms, so it's a SOP. These are the evaluations from variable to the 0101 values. So A complement or A bar is nothing but the value of 0 because we are studying a SOP expression mapping. B complement is nothing but 0. C complement, the value of C is nothing but 0. So here similar case, the A complement, B complement, the value is 0, whereas the C is without complement. So that's why the value of C is, we are taking here a 1. In case of A, B and C bar, 1, 1, 0 we are getting, and in case of A, B bar, C bar, we are getting a 1, 0, 0. Now these are the 3 variables, so we have to draw a 3 variable K map, but for SOP. And we are arranging this 8 cell K map for the 3 variable input logic. Now one by one we have to represent it, this first value, second, third and fourth product terms. The first product terms is nothing but A bar, B bar, C. Where is the A bar, B bar, C? So you have to calculate from the A bar, B bar, C from this variable also, or otherwise you have to calculating from the 0, 0 language also, 0, 1 language also. So A and B value is the 0, 0. So A and B value is the 0, 0. So these are the row. So out of these 2 row, which one is the value of this particular product terms? So it can be given by the third variable value, which is 0. So 0, 0 AB, and the C value is 0. So that's why this is the first locations where you have to representing this first product terms. But we are not directly representing the product terms, we are representing the product terms in the form of 1. We are placing the 1. Now for the second A bar, B bar, C, this is the location, and we are indicating or express in the form of 1s in that particular locations. Similarly for the third value, we are mapping the 1, and in case of fourth value, we are also mapping the 1. So this is the expressions, and we are mapping these 4 product terms is like that in the K map. So the mapping of K map is also important, and the next steps we are moved to the grouping also. But before we are going to be groupings, you have to practicing these 3 standard SOP expressions for mapping purpose, and once you are expert in the mapping the K map, then we move to the grouping of these ones. Also these are the SOP expressions for your homework or as an assignment, you have to take it for mapping, but this is a non-standard SOP expressions. So one more things you have to done here, that is nothing but you have to firstly convert the non-standard SOP into SOP, standard SOP, and then that standard SOP you have to map into a K map. Grouping of ones, the rules is there. The group must be contain either 1, 2, 4, 8 and 16 cell. We are making a group of 1 also, and we are making a group of 1 variable, it's called as the individual. We are making a group of 2 variables, we call it as the pair. In case of group of 4 variables, we call it as a quadra, and in case of 8 variable groupings, we call it as a octa. Here in case of 16 cell grouping is nothing but hexa. So that is the name is given, otherwise you have to keep in mind for 1, 2, 4, 8 and 16 cell grouping is allowed in case of ones, and we are making a group of only the ones in case of SOP, while in case of POS you are making a grouping of 0 also. Okay. Each cell in the group must be adjacent to one or more cell in that same group, but all cells in the group do not have to be adjacent to each other. Means while we are grouping, you have to keep in mind the cell adjacency. As per according to cell adjacency, so only the vertical and horizontal cells are adjacent to each other, as well as the corner to corner cells is also adjacent to each other, but the diagonally cells are not adjacent, and we are not making a grouping by diagonally in case of K-map. Always include the largest possible number of ones in a group in accordance with the rules number 1. Means largest possible numbers grouping try to make, because the largest grouping of ones is nothing but list variables we are getting as output of the K-map, and which indirectly reducing the required logic gates for design of that particular digital circuits. Okay, so the largest possible number of ones means these are the number of groupings is allowed. So we try to group of ones firstly 16 cell. If it is not possible, then we are taking the second priority for 8 cell. If the 8 cell grouping is not possible in the K-map, then you have to move toward the 4 cell and so on. So the priority is the largest possible number of ones, that is the 16 priorities. First priority is given to a 16 cell grouping. If it is not possible, then you have to move toward the 8 cells, 4 cell, 2 cell, and subsequently the individual, that is nothing but single cell group also. So these are the rules, and we have to directly see in the one of the examples how we are grouping the ones. Here in this case, the mapping is already done, and we are going to be grouping the ones in this first examples. So we have to clearly see these two cells are adjacent to each other, as well as the two cells containing the ones. So that's why this is the first grouping we are making here. These are the pair. But priority, according to priority, if we considering 16 ones is not available, even though these are the only the 3 variables, so that's why 16 cell is not available. So the priority for these 3 variables, the highest priority goes to the 8 groupings, 8 cell grouping. So here the 8 ones is not available, so that's why we are thinking about the 4, but the 4 ones is not adjacent to each other. 4 ones is present, but they are not adjacent to each other, so that's why the 4 ones grouping is not possible here in this example. So that's why we move to the pair. Pair is possible. Ask to question yourself, if it is S, so make it the group of the pair of ones. So we are making this first group, then these two are also adjacent. Here one of the rules is keep in mind, overlapping is also allowed. Okay, because so many students is asking that if this one is can be covered by this first grouping of the ones, then is it possible to make it again for the grouping with the neighboring another one, single ones? So yes, overlapping is allowed, and we are making the overlapping and making the groups also. Now what's about this single one? The single one, there is no adjacent, because all the adjacent cell of this one is empty. There is no ones is nearby is available in order to make a group. So that's why this is the individual. Individual is nothing but single group is there. Single ones is there. Okay. Now in case of the second examples, now see here the one from the upper cells is grouping with the ones of the lower cells, because the corner to corner cells are adjacent to each other. In case of this two cells, these are adjacent, so that's why we are making the pair. In case of this two one, it is also a pair. So this is the grouping of ones. In case of 16 cell, so first examples you have to see here. These 4 ones is adjacent to each other, so this 4-1 grouping is possible, as well as this 4-1 is also adjacent to each other, so this 4 grouping is also available. So we are making the first quadra, these are the second quadra, and what's about these two ones? These are ones are adjacent to each other, so we are making the pair of them. So two quadra and single pair. In case of second example, so you have to clearly see in that the 4 quadra is there, but from the right most corner cells is also the 4 quadra is there. So this 4 quadra and this 4 quadra are adjacent to each other because the rightmost cell is adjacent to the leftmost cell. So that's why we are making this octa. We are making the group is group of the 8 ones, 8 cell group. Now what's about this 2? It is possible to make a group of pair, but we are already studied the rule. Try to make a largest cell group. So we are making this 1-1 group with these two another 1-1 groups in order to make this as a quadra. Okay, so pair is possible, quadra is possible, but the highest priority is given. So that's why we are making the quadra in this case. Now in this case the individual is possible as well as the pair is possible. So which priority is given? Priority is for the pair is highest, so that's why we are making the pair for this one. In this way we are making the grouping of ones. Now after groupings, in this way after groupings we have to find out the expression, that is the final step of this schema. And for these examples we have to see here we are making the group of this octa. So from the AB sides you have to see in, from the row sides of AB we have to see in the value of AB is 0-1 and the value of AB is 1-1, and it can be switching from the 0-1 to 1-1. Okay, while switching those variables are changing their bits, we are neglecting that variables, and those variables only the constant throughout this row, that is nothing but the output expression for this whole grouping. Means the octa groupings in case of these row sides the 1 and 1 is same, so that's why 1 and 1 value is assigned to the B value, so that's why output variable as an expression we are getting as a B. But the A is changing from 0 to 1, so that's why we are neglecting that A. Similarly in case of, if we considering the column case, so column case the 4 all columns is comparing to each other, and here it can be seen that each and every value is going to be changes. C here 0, the C is here 0, but here it can be changing to 1, so that's why C is neglecting. Here in case of D is 0, D is changing to the 1, so that's why D is also neglecting. So for this octa grouping we are getting a single variable output which is named as B. Now if we are making the quadra of this 4 ones group, so from the row sides we are seeing these two values are comparing, and from comparing it is seen that the value of A is constant whereas the value of B is changing from 0 to 1, so the B is neglecting only the A from the row sides we are getting. So A from the row side. Now similarly we are calculating from the column side. Column side these two values is going to be compared to each other. So the 1 and 1, the value of C is constant, but the value of this D 1 to 0 is switching, so that's why the D variable is ignoring. So from the row side we are getting the A, and from the column side the value of C is constant, so we are getting the C. So it is the A complement B. The value of A is the 0, so that's why 0 in case of SOP. So 59 it's a variable complement, so that's why it's a complement C. So in this way we are going to be calculate the expression from the grouping. Now this single one, but we are making the pair with the adjacent one, and from that pairs, if we calculating the value from the row sides, so these two value are comparing, and from the comparison it is clearly seen that the value of A is constant, whereas the value of B is changing from 1 to 0. So that's why the B is neglected, and only from the row side the A is available, which is the value of 1. So that's why without complement is available. Whereas in case of column side of this pair, you have to see only the single value. There is no another value for comparing. So that's why this whole term C and D from the column side we are taking as a output expression variables, and from row side we are only taking the A value. So the A, and it's a CD. So the A, it's a C bar D. Where the C bar? Why C bar? Because the C value is the 0. So 0 in case of SOP we are taking a variable complement. So in this way, from the pair we are getting A C bar D. From this octa we are getting the variable B, and from this group of this quadra we are getting A bar C. And this is the SOP, and we are getting these product terms. So we are making the sum of these product terms, and we are getting the finalized expression of this K map as B ORing with A bar C ORing with A C bar D. So determine the minimum SOP expressions from the K maps. From this first, these are the individual, because there is no adjacent ones for grouping is available. In case of this pair and in case of this pair. So if we see the first individual from the row side, it's the AB, and the value both is the 0. So we call it as the A bar B bar, because we are studying the SOP form expression. So A bar B bar from the row side, and from the column side we are getting the C bar. So A bar B bar C for this individual, and for this second pair we are getting the value AB only, whereas the C value is cancelled to each other, because we are comparing for column side. The value is C is changing from 0 to 1 or 1 to 0. So that's why we are neglecting the value C. For this pair we are only getting the value from the row side, which is 1 1. So that's why it's a AB. For this pair, third pair, we are getting the column side as a C, and from the row side these two values is going to be compared, where the value of A is changing but the value of B is constant. So from row side the value of B variables we are getting, and from column side C is getting. So BC, that is the output expression for this exercise. Now you have to solve as a assignment for this grouping. We are making the grouping of this pair like this. These are the corner pair. We are making with the corner to corner adjacent to each other pair, and in this way we are getting the output expression like this. If we are making a grouping in case of 4 variables like that, this quadra we are making, this quadra we are making, this pair we are making, and finally we are getting the expressions A bar B, A bar C bar, A B bar D, and those are summation of these product terms. Similarly, for this second exercise, it is also given that the corner to corner are grouping as octa. These we are making a quadra, and these we are making a pair, and from this 4 we are getting this output expressions. Now these are again a K map for SOP, and each and every terms you have to first steps you have to mapping the each and every product terms in the K map, and then we move to the grouping of the K map, and then finalize from the groupings you have to find out the expressions for this practicing K map. Answer is there for both cases. How we are mapping from truth tables? If there is a SOP, so we have to concentrating the output as a 1. Once the output is the 1, so that values we are mapping according to their location, where the first value is we are mapping here. Why? Because the value of A is 0, value of B is 0, value of C is 0, and that's why this is the location where the value of A, B, C is the 0. Similarly, for this one we are mapping directly from the value of A is 1, B and C is 0. So here clearly shown that from the row side the value of A is the 1, value of B is the 0, and from the column side the value of C is the 0. So it's a 1 0 0. Similarly for this third ones and the fourth ones we are mapping, and remaining all is nothing but zeros in case of SOP. In case of don't care condition, in case of BCD, binary coded decimal, is only showing the output up to the 9, and after that 9 all the digits are invalid. So that's why the 6 invalid combinations is available: 10, 11, 12, 13, 14 and finally 15. So these invalid combinations we express in the K-map with the help of don't care. Don't care we are express by the cross sign. The meaning of that cross sign is nothing but you have to don't care about whether it is a 0 or 1. As per according to your application, if we want to make a major group with the help of this don't care, so you have to carry out. For examples, this is the output of BCD where the 0 to 9 output can be generated, but 10, 11, 12, 13, 14 and 15, this output is invalid in case of BCD, or there is a something much more applications there where the don't care we are going to be utilized. So only this 1 1 3 ones is available as output, so we are mapping in the K map. But if we mapping the don't care, so we have to see in like that. So that cross signs, either you have to assume it as a ones or either you have to assume it as a 0. But we are solving for the SOP, and if you want to make the group of this octa, then we assuming this cross as a ones. So that's why without don't care only the pair and individual, and we are getting the output expression is like that. But if we with don't care, if we are making a group, then that times we are getting the output expression is like that. Y is nothing but A ORing with B, C, D. So if we are comparing these two expressions, you have to clearly see that without don't care the variable is much more. So logic gates required for this is also high number or large number logic gates is required as compared to the with don't care output expression. So don't care, if you are required then use it for the grouping, otherwise leave it for grouping. So that is the don't care condition. Mapping of the standard POS expression. Similarly for this A, B and C, which is the sum terms, in case of POS, so keep in mind 1 is nothing but the complements, and without complement variable is nothing but 0 in case of POS. So we are indicating each and every value in the form of their evaluating 0 and 1 language, and these are the 3 variables K maps. So the 3 variable K maps we are showing the each and every value as per according to their location. But in case of POS we are showing it by the 0. So that second value, second sum terms we are showing by the 0. Third terms we are to indicating or mapping. Fourth terms is again mapping. So in this way, in case of standard POS expressions, we are mapping in the K map. Similarly as the SOP, just difference is like that. Instead of ones we are representing by the 0, and the logic for SOP and SOP and POS is like that. In case of SOP, 0 is complement, 0 is meaning is nothing but complement, or complements of variable is nothing but 0. Whereas in case of POS expression, the 0 is nothing but without complements and 1 is nothing but complement. That is this. So this is the K-map simplification for the POS expressions. So 3 variables. This first we are indicating here, the second sum terms, the third sum terms, fourth sum terms and the fifth sum terms. And then we are moved to the groupings. After groupings we are finding the expression from that particular groups. These are the pair. From that pairs you are getting the B bar plus with C, or B ORing with C. and we are getting the output as a B bar ORing with C. Remaining all the vacant place is nothing but the ones, that is the SOP, that is the product terms. Okay, so this is all about this fourth module K-map. So thanks for watching this video. If you have any query, so ask me anytime on my personal gmail.coms or my official mail.coms and my WhatsApp contacts. Thank you.